Good morning, Trig. This is lesson 43. This lesson is so important. I have downloaded a blank copy of the graphs we're going to be studying today so that you guys could print those or write on it using Notability. I would save it. I would keep these parent functions near you because we are going to be graphing periodic functions quite often the rest of the year. So super important you print that blank PDF. All right, so 43.A covers periodic functions, and periodic functions have a repeating pattern. So it's a graph that, like, you can see, like, it has, like, for example, okay, that is a repeating pattern. The height of the curve is the same all the way throughout the graph. Now, examples of these are called sinusoids. Or maybe they're pronounced sinusoids. I'm pretty sure it's sinusoids. And sinusoids describe a curve that looks like the sine curve. Whoops, I spelled curve wrong. Now, both sine and cosine are sinusoids. So if it tells you to graph or write the equation of the following sinusoid, know that sine and cosine are both considered sinusoids, and that's because they have a repeating pattern. Okay, and that's all that 43.A goes over. So periodic functions. Periodic involves sine, cosine, and tangent. Sinusoids specifically cover sine and cosine, okay? And that is just going over the vocabulary. 43.B is an introduction to their graphs. So this is going to go over the unit circle and the graphs of sine and cosine. And so I'm going to do the basic graph that we're going to base all others after. So that's why there is a PDF for you to print that includes their graphs. So let's talk about first, let's talk about the unit circle. All right, I have this unit circle. And here's my y-axis. Again, this is just an estimate. Here is my x-axis. Now we know that in our unit circle, our radius equals 1. So this point here is at 0. This point here is at 1, 0. This point here, right, is 0, 1, because my radius is 1. Over here, that would be -1, 0, and down here is 0, -1. Now, I think it's also important that we note that at each of these, we have a degree measure and a radian measure. So, for example, this here, right, this is 0 degrees. Okay, remember, angles start at the x-axis going counterclockwise. So this up here would be 90 degrees. Down here on the left, that would be 180 degrees. Down here would be 270 degrees. And then if I came back up here, I'm now at a full 360. Now we can keep going, right? If I kept going, this would also, another 90 degrees would be 450, right? We can keep going. This would be 540. This would be, I think, 620, or is it 630? 630, sorry, I was having to add 90 in my head, and then this would be, again, 720. Now, each of these also has a radian measure, which we will go over later, but for example, and I don't want to confuse anyone, 360 is 2 pi, 90 is pi over 2, 180, that's just pi, 270 is 3 pi over 2, or 1.5 pi's. So I want to also go over a couple of things. We've got degrees, and we have radians. Degrees are when we have the little bubble. Radians are when we have the mention of pi. Okay, so know that we're going to have both. We are also going to be talking about the amplitude, and I will get there. But let's first start with sine and cosine. Now, when I read this unit circle, the sine of theta is my y value, and the cosine of theta equals my x value. Okay, so this is all from Algebra 2. This is basic unit circle information. Remember, you can always Google it or rewatch this video. So we are going to jump in, and we are going to graph y equals the sine of theta. Now, when I see the sine of theta, and that is referring to degrees. Okay, so I'm going to go ahead and build a table. We're going to graph it, and then we will move on to cosine. So you can see the parent function here. So I have x, or theta, and y. Okay, if that helps. So I'm going to start with my, I'll start with positive. So 0, 90 degrees, 180, 360. And then I'm going to do the negative value. Oh, whoops, I skipped 270. And that way you can see the graph. I'm not going to do any decimals today. I'm just going to use perfect values, 270, 360. And then I'm also going to do the negative values, so negative 90, negative 180, negative 270, and negative 360. Okay. And I'm going to find all these values based on the unit circle. So this is in degrees, okay, and we'll label it later with radians in case they do give you radians. So y equals the sine of theta would mean we're using degrees. If I had y equals the sine of x, then that means that the graph should be in radians or in terms of pi. And I can write those on the left, right? 0 in radians would still be 0, but this is pi over 2 pi. 3 pi over 2, 2 pi. Okay, those are the radian values. And remember, radian equals 180. So the reason why 90 is pi over 2, because 180 divided by 2, or pi radians, is 90. Pi is 180. This is 3 times 180 divided by 2, which is 270. So these do have the same value. So down here, negative 90 would just be negative pi, or negative pi radians over 2, negative radians, negative 3 pi over 2, negative 2 pi. Okay, so if you see, that's to differentiate the two. All right, so using our unit circle, we're going to fill this out. So at 0 degrees, sine should be the y value. So my y value at 0 degrees is 0. 90 degrees, go to 90 degrees, my y value is 1. So I'm filling in the table. At 180 degrees, my y value is 0. Okay, I'm going to move this up a little bit. At 270 degrees, the y value is negative 1. At 360, I'm back to 0. Okay, now this pattern would keep going. Anyone guess what the next number is? So for example, at 450, right up here, I'd be back at 1. And then it would go 0, negative 1, 0, positive 1, 0, negative 1. That's the repeating pattern here. Now, negative. So remember, negative means I'm going clockwise. So this would be negative 90, which my y value is negative 1. I'm recording this in my table. At negative 180, my y value is 0. Negative 270, my y value is 1. Negative 360, my y value is 0. So let's graph that, and that'll give you your parent function, and we'll talk about amplitude. And I might have to make this graph much longer. Now remember, you're going to be graphing these and writing the equation. So let's talk about my radius is either 1, so on the way of y-axis 1, or the lowest is negative 1. So that is what the graph should look like there. I'm going to label mine in degrees, so I'm going to go by, this is 45, 90, 135, 180. So every 2 boxes I'm going 90. 270, 360, and just to show you that this repeats, 45. Okay, now in the opposite direction, right, this would be negative 90, negative 180, negative 270, negative 360. Okay, now I'm doing mine in degrees. Okay, I'm using theta. If I was using radians, then this would be labeled pi over 2. And this would be pi. And this would be 3 pi over 2. And this would be 2 pi. And this would be, this would be 4 pi over 3. Or, I don't know, but it has a radian value. So here we go. I'm going to graph this. So I have 0, 0. 90 degrees, I'm 1. At 180, I'm 0. 270, I'm negative 1. 360, I'm 0. At 450, I'm 1. Now, when I connect these, it should be a smooth curve. Okay, we're not going to make these pointy. We could have plugged in like 45, 135, 330, but that would have given us decimals. And then I'm going to use an arrow. Use arrows when you graph this. Now I'm going to do the negative value. So negative 90 is negative 1. I'm just looking at my table. Negative 180 is 0, 1, 0. So here is a periodic function because the pattern is repeating 0, 1, 0, negative 1, 0, 1, 0, negative 1. And it keeps repeating. It also forms this beautiful like wave-like shape. So I know that this is 1 because radius is 1, but there is also another term called, this is from the x-axis to the point at which our peaks are labeled. That is called the amplitude. And our amplitude for sine of theta is 1 because the radius of unit circle is 1. Okay, so our amplitude is 1. It should be the same down here. Our amplitude is still 1 down here. Okay, our amplitude is the same top and bottom, so it should be a distance of 1 here, and from the x-axis down, it should be a distance of 1. Okay, so this is the basic sine function. So moving on, let's talk about cosine. So I have y equals the cosine of theta. Now note if this said y equals the cosine of x, then our graph should be in radians. This means our graph should be in degrees. Okay, so I know the difference there. So we're going to build our table based on the same degree measures that we did for sine. So let's say theta, here's our y value. So 0, 90, 180, 270, 360 if you want to go all the way to 450. And then I'm going to do the negative. Negative 90, negative 180, negative 270, negative 360. Now, I know that the cosine of theta equals my x value. So we're going to fill out this table using our unit circle. So when I'm at 0 degrees, x is 1. When I'm at 90 degrees, my x value is 0. When I'm at 180 degrees, my x value is negative 1. At 270, the x value is 0. Notice the pattern is similar. The difference is where our pattern starts. And we'll compare those in a second. So at 360, I'm back to 1. And maybe you see the pattern, then 0, then negative 1, then 0, right? If I continued to go positive. But I'm switching it. We're going to go back to the 0. We're going to go negative 90 degrees. My x value is 0. Negative 180, negative 1. Negative 270, 0, 1. Okay, so the pattern stopped, but that's because I went in the reverse direction. So let's compare these because that's going to be really important for you. When I have the sine of theta, my starting place is 0, 0. Really focus in on that. When I'm talking about the cosine of theta, notice that first point is 0, 1. And that is how you're going to be able to tell the two apart. It's the same pattern, but where it starts is different. Sine will start at the origin when I draw my pattern. Cosine starts at 0, 1. Okay, so if I am to draw this, these are going to look very similar. Okay, their graphs almost look identical, but the starting place is different. I will expect that your graphs are on graph paper, so either invest in graph paper or print it off the internet, type in grid paper. Okay, so 90, 180, I'm going to label it the same, 270, 360, this would be negative 90, negative 180, negative 270, negative 360. If I kept going, this would be 450. So I've labeled every 2 boxes. So I'm starting with what they gave me at 0, I'm at 1, 90, 0, 180, negative 1, 0, 1, 0. The next point would be negative 1, right? It's a pattern. 1, 0, negative 1, 0, 1, 0, negative 1, and it keeps going. If I go to the left, I'm going back 0, negative 1, 0, positive 1. So my cosine looks very similar. Remember, we should draw arrows at the end because this graph continues on a repeating pattern. It doesn't just stop just because our drawing stops. So anytime you graph, if this is a continuous function, then you need arrows at the end. So this would be the parent function of y equals the cosine of theta. Notice again, my amplitude is still 1 because the radius of my unit circle is 1. Okay. I also want you to notice the graphs of the two. Okay. We use the same degrees, we have the same amplitude, just note it, and they have the same shape, they have the same pattern. The difference is our starting point. Cosine starts at 0, 1. Sine is at 0, 0. Okay, so we're going to practice some of these. I am going to go over kind of like the standard form of our function. Oh, sorry, I shouldn't put formula. Function, I should just put the function. So y equals a times the sine of theta. Or this would be y equals a times the sine of x. It just depends on if it's in degrees or radians. Or y equals a times the cosine of theta. Or y equals a times the cosine of x. Remember, this just means we're going to have it measured in radians. This is in degrees. A represents your amplitude. Okay? And that'll tell you either if there's nothing there, then it's a 1, or they will label it. If it is, it also will represent if there is a reflection. In that case, A is a negative A. And when I say reflection, I mean across the x-axis. So we're going to write the equations for several functions. I have attached this paper in the notes so that you will have it. Okay, and you could do it along with me. Here is my parent function for sine. It's just a little snippet. And here is the parent function for y redrawn for you, so we have them at the top. So in the first column, I have sine functions, and we're going to practice writing their equations. So hopefully you can see this. So for part A, now, a couple of things. I notice the starting place is at 0, 0, so I know this is sine. I notice that these are in degrees, so I know my equation is going to be labeled with theta. And then I'm going to look here at my amplitude. My peaks and my valleys are at 2, so I know my amplitude is 2. Because the distance from the x-axis to the top is 2, and the distance from the x-axis to the bottom is 2. So when I go to write my equation, I know this is sine. I know it's theta, but my amplitude is no longer an invisible 1, it's 2. And so that is the equation for this function. Okay, I know it's sine because of where it started, plus I put all the sine functions in this column, and the book will usually tell you if it's sine or cosine, okay, because they look so similar, the book will tell you. So I'm telling you this whole column is sine functions. All right, part B. Again, it's in degrees. So I know my equation will involve theta. I see that it hasn't been shifted. It's at 0, 0. But I noticed that instead of at 90 at positive 1, my graph has been flipped down. So because of that, because I know it should be at positive 1, it's at negative 1, then I know there has been a reflection. But I notice my amplitude is still 1. Okay, so there my amplitude is still 1. So I would write y equals a negative 1 sine of theta, because it's in degrees, so it's theta and not the x. My amplitude is 1, but I don't really need a 1, so I could label this as y equals negative sine of theta. Okay. Last one for sine. Oh, I see that they labeled this graph with radians, so I'm going to use x in my equation. I also noticed that my amplitude from top to bottom is 3. So my amplitude is 3. I also know that my point should go from 0, and my graph should start, and then I should go up, down, up. Okay? So if I'm not going up right away, then I know it's been reflected. So since this graph starts from the origin and goes down, I know that there has been a reflection. So this first point tells me there's been a reflection. So my equation should be a negative 3. 3 because that's the height, and negative because it's been reflected, and it has to be the sine of x because it's in radians. Okay. All right, now we're going to switch gears. The following equations are examples of the cosine function. Now I know that cosine starts not at the origin, but its beginning place is at 0, 1, okay? Sorry, I had some coffee. So let's start with this first one. This tells me this is radians, so my equation involves x. If you look closely, both of these, the height and the depth is 4, so my amplitude is 4. And it has not been reflected. The point is at the top in the beginning, so there's been no reflection. But my amplitude, so 4 cosine x, it's x because we have radians and not degrees. So that would be the equation. The bottom one, I know the point should be here. So because it's down here, that tells me that there has been a reflection. The degrees, this got cut off, degrees tells me to use theta. Now I notice that my amplitude is just 1. So y equals negative 1 cosine of theta. I don't need the 1, so I can just write y equals negative cosine theta. Okay, now homework. Let's go back to here because that completes lesson 43. So for homework, 43, you are going to skip numbers. Sorry, I had to pull out the homework. You're not too many. 5, 22, 24, 29, and 30. Thank you.